Welcome to part 1 of the series. Since this is a professional level exam, so we'll be learning everything by doing the hands-on. So this is the DynamoDB. We'll cover the first part as DynamoDB. So we'll be covering real life projects which we can apply in day-to-day business as well. So here the agenda is first to create point-in-time restore of a DynamoDB table and also on-demand backup. So what is the use case of it? Say for any point of time in our business or project, we want to roll back our data. So let's now begin with the hands-on. Alright, we are at the AWS console. So let's check what's there in the architecture diagram. So the first step is, this is me as a user. So I'm using the AWS console. We'll be uploading CSV files, 2 CSV files to store in S3. Why we are uploading files? Because we will automate this process. We are not going to manually insert the data in DynamoDB table. Instead, we'll use Lambda for it. So let's begin with it. So let's go to S3. So we'll be doing everything from the scratch. So we need to definitely create one bucket as well. So let's give it a unique name, the uppercase. So let's type it. So our bucket is ready. So let's open it and upload the files from our local computer. So I have 2 files. So let's upload these files to our S3 bucket. So we'll be inserting the same data in the DynamoDB table. So since this data is uploaded, files are uploaded, let's check the architecture diagram and carry out with the next step. So the next step is to create one DynamoDB table. So let's go back. So let's duplicate this tab because our Lambda is automated. So we'll be needing the names of these files as well. So DynamoDB, let's open it. So let's now go ahead and create table. So we can give it a name. So before giving a name, so let's check what's the name given in the code, like the Python code which I have written. So it's Blockbuster Films. I'll copy paste this same thing. So the name is Blockbuster Films. So let's undo Blockbuster. I'll give the name as rating. So there's a partition key. Let us give it like a string format. Let's create this table. The table is creating. So next step is like we need the Lambda. If you look here, so Lambda will reads the CSV files in the S3 bucket. Then it will put the data, same data, in the DynamoDB table. So that's what our task is all about. So the table is created. So if we look at the table currently, under like if we can go to the backup, so point in time PITR, that is, it is off. If you see the status as off. So in order to achieve this task, point in time restore recovery, that is, if you want to roll back the data to previous any time, let's say current time is 11 AM, I want to roll back data to 10 AM, so we need to enable it. So that's what is the concept of point in time. So we need to check this, turn on this point in time. Simple. We'll need to save it. So it's on. So let's go back to now Lambda. We'll be creating one function from the scratch. The code we have already there in our file. So let's create one function. Function name will be, let's give it any name, DynamoDB automate kind of. So we are writing code in 3.9 maybe. Let's select 3.9. Under advanced settings, we don't need anything. Let's select use an existing role. I have made it simple for you. So let's I've already created one role. So let's check what's there in the role. So if I expand this role, its simple action is like DynamoDB allow full access. Star is there, all the resources. if we scroll down a bit, also there is S3, there is star. So we are allowed to do everything with respect to S3 and DynamoDB in a nutshell. That is what the function is all about. So let's go ahead and create the function. The function is created. So next task would be to write the Python code. So I'm already having the Python code here. So let's copy paste this one. So yep, we are done with the copy pasting. So let's verify few things. So we need to make sure this table name is same as the DynamoDB. So Blockbuster Films exactly same, lowercase. So that is what is required. Partition keys and all those will be under the ratings. Let's put the data by running the DynamoDB, like running the Lambda. So we need to deploy it first. So once it's deployed, let's configure test events. So I can write it Lambda DynamoDB. So under templates, we'll be using put S3 template. So let's modify some of the things like the bucket name. So I'll be copy pasting the bucket name. We need exactly same so that Lambda can understand what we are trying to do. So here under the name, bucket name, and under the object key means this is the file name. So we'll be, since we are putting files one by one, so let's copy paste. Let's go to the Lambda, paste. So yes, we are done. So this is the one of our CSV file name, first file, and this is our bucket name. So that's how put event work. Let's save it. So let's now check. Yeah, it's selected to this dot, you can see. So let's test. If any kind of error, we won't get. So there is no error because we are able to see the data. So let's now verify this on our table as well. So let's go to the tables once again, and here we are getting one new item. If you look, get live account. If we check, so see now 50 records are there in the table. We can also do explore items to view the data as well. So we can click on run. So yep, that's how we can also check. So 50 records are there. So we need to note the time. So it's currently 16:13. Since we are doing point in time restore, so noting the time is very essential. All right, since it's already 3 to 4 minutes, so we are good to upload or load the next set of data. Like currently we had like 50 records as shown. So let's update with a new set of data. So let's go back to the DynamoDB, like Lambda, configure test event. So here the only change will be our CSV file name because bucket name is same. So let's copy paste this thing. Here we need to change the name, save, then execute. Let's check it's the same. Okay, let's test. See, we have got the new data here, so it's successful, I can say. So let's also verify from the DynamoDB. Let's go to get live event count. So check, see, it's updated to 60. So 10 records automatically got inserted using Lambda. So this was the architecture diagram. If you see, so we have uploaded two files, S3. Lambda has done the updating or loading the data into the DynamoDB. So next task is our to do point in time recovery or on demand backup or recovery. So at 16:13 or 16:14, I'll say we had 50 records, and at 16:17 we had 60 records. So now let's see, if I want to roll back to 50 records, that is a previous value, 50 records, then like what should be our step? So let's check it out. Under backup, we have point in time restore. So let's click on restore. So here we have the option, let's mention the name Blockbuster 50. We can give any name since we want 50 records now. So I'm making it easy, the table name, that is 50 records for 50 name. We can specify custom time. So I'll specify a custom time because I'm sure that at 1614 there were only 50 records. So let's mention 16, 14, 20. There were we don't want to do anything more. We'll select on restore. So this restore process is I'll see it takes some time. We can see it under the let's refresh this. Yeah, it's popping up, we can see. So it's restoring. Please note the restore process is independent of the data present. Do not think like if it is 100 records it will take double time, or it is 50 records it should take half a time. No, the concept is wrong. It will restore process is independent of that data. Somewhat what I've learned from my past experience. So it's restoring. So meanwhile, let's duplicate this tab as well, since here Blockbuster 50 will be restoring 50 records, and there is another version of it, like in Blockbuster Films. If you open this, so current record is 60. If we click here, select live, it will be doing the scan. It's 60, right? So let's say we want to take a backup of the 60 items as well. Like let's say someday if my supervisor says, okay, why didn't you have the backup of 60 items? We require it now. So for the safety purpose, let's assume those kind of scenarios will be doing one backup. Let's click on backup. Let's go down, create backup. So we can write backup 60. So this is not the table name, no, just it is the backup name. So we want to backup, we want the backup as a table, right? So let's create the backup. It is usually a fast process. So yeah, the backup, the status is available. So let's click on this backup, and there is a restore button, right? So in order to restore the table, we need to click on restore. So now it's asking for the restore table name, what we want. So I'll be writing restore table restore table 60 for 60 records. So we'll be having both the flavors. That is our first file, if we look, had 50 records and second has 10 records. So we will have both the flavors of like 50 DynamoDB table, 150 records table, and 160 records table. So that's what is our task. So we can we can roll back the data or use the backup to switch to any of the table, right? So let's go down and click on restore. So it's in progress. So under the tables, if we click on right click, it takes some time. Okay, so our Blockbuster 50 table is now ready. So let's view the data there. So if we go there, so let's take it a live count. So the live count will see 50. So the first file which we have uploaded, there was 50 records. So we got the point in time restore. So that is the purpose. Let's say we want to roll back to previous time. So this process is done. All right, under the table section, now it takes some time for the restore version of the table, like 60 record. For the backup version, it takes some time, and once it's activated, it's done. You'll directly see the status is active. So let's open this. So under restore, if we get the live count here, let's check the live count. Yep, 60. So we have both the versions, right? 60 records and also 50 records table. So that's what our agenda was, to create point in time restore and backup as per this architecture diagram. So I hope you found this tutorial helpful. All right, let's look at this question. Always mark the keyword just like we have done in associate or foundational level cloud practitioner exam, because it will help us to identify at the correct answer. So just like my previous series, AWS Solutions Architect Associate, I'll be marking some of the highlighting or the important keywords in the options itself so as to simplify the answers. So in blue, I'll be highlighting generally the incorrect options, and in orange, I'll be marking the correct options. So let's first look at option A. A says introduce an Amazon Elastic Cache cluster to work alongside the DynamoDB table. So why this highlighting is necessary? Because it will help you to save time in real exam, because you might be running out of time. So we need to narrow down our answers, and we need to arrive at the correct answer as quickly as possible. So if you look at this option, deploying Amazon Elastic Cache cluster would introduce additional cost for the caching service, which may not be the cost effective solution as using DynamoDB Accelerator. DynamoDB Accelerator is specifically designed to work with DynamoDB. That being said, if the question is about DynamoDB, then we need a caching mechanism. Then if there is a need of caching mechanism, then DynamoDB Accelerator will be the one of the best choice automatically. So hence Elastic Cache is incorrect. Let's move to option B. B says implement DynamoDB Accelerator, also known as DAX. Adjust DynamoDB's auto scale settings and not for savings plan in Cost Explorer. So DynamoDB Accelerator looks good to tackle the problem of repeated lookups as required by the question, but the problem is that it won't solve the problem of burst as required by the question. Hence we'll eliminate this option. Let's now look at option C. C says switch to a provisioned capacity mode for DynamoDB and commit to savings plan in Cost Explorer. So provisioned capacity mode looks good because it can solve the problem of avoiding burst as required by the question here, but it won't solve the problem of caching as required by the question. As per the question, we have unpredictable workloads. Provisioned capacity mode works for predictable capacity needs. This may lead to over provisioning and higher cost, therefore incorrect choice. We are left off with option D. It says set up DAX, switch to a provisioned capacity mode for DynamoDB and enable auto scaling for the DynamoDB database. Since the problem of repeated lookups can be taken care by DynamoDB Accelerator, also known as DAX, and to avoid the burst, that is our second part of the question, we need provisioned capacity. So this brings us to the correct answer, and we'll log this. Alright, let's tackle this question. We'll first look at option A and B because both looks almost similar. Only difference is read capacity unit and B says write capacity units. So as per the question, it's mentioned that DynamoDB suffers performance issues when data is saved. If you look here, since saving the data is associated with writing the data to DynamoDB table, hence we need to increase the write capacity units. Hence we'll reject option A and keep option B because the question is looking for two correct answers. So let's park this. Now let's look at option C. C says implement an Amazon Elastic Cache layer to boost performance of Lambda function. Since Elastic Cache cannot solve the problem of concurrency as with Lambda or performance issues with DynamoDB. Moreover, as mentioned in the previous question as well, with the hint which I have given, if the question is about DynamoDB, then for caching related problems, DynamoDB Accelerator can be the best fit if there is an option present. Hence, for now, Elastic Cache is incorrect. Let's now move to option D. Option D says introduce an Amazon SQSQ and logic for reprocessing between Amazon S3 and the Lambda function. Adding an Amazon SQSQ can help manage the load by decoupling the upload process between Amazon S3 and Lambda function processing. This decouples photo upload from processing, prevents Lambda overload, and offers retry capabilities. This can be the potential answer. So SQSQ comes into picture whenever there is a scenario we require for decoupling. So it is a perfect scenario for decoupling if we read the question. This looks good. Let's park this. Let's move to option E. E says utilize S3 transfer acceleration to reduce latency for users. So S3 transfer acceleration is beneficial for speeding up the transfer of large files over long distances. As per the question, we have no requirement of transferring the files over long distance, and also the size of the photographs is unknown. Perhaps they can be small size like few kilobytes or megabytes even. Moreover, S3 transfer acceleration does not address the problem of concurrency with Lambda or the performance issues with DynamoDB as required by the question. Just like we eliminated option C. This is again incorrect choice. We are left out with two answers and we'll log this. Let's bring the heat to the snow. We'll first look at option A. So if you look at option A, it does not include any enforcement mechanism to ensure that all future resources will have the required tags. Hence, incorrect choice. Let's move to option B. So if you look at option B, it only provides a reactive solution with an AWS config rule to alert on untagged resources and does not prevent the creation of resources without the required tags. Therefore, again, incorrect choice. Now let's move to option C. So as per the question, it's mentioned that there is no consistent tagging strategy across the organization, but there are guidelines in place that require all infrastructure to be deployed using AWS CloudFormation with consistent tagging, which means we need to use SCP to meet this requirement. Since there is a mention of SCP, we'll park this. Let's now move to option D. If we read option D, option D is incorrect because it only updates existing federated roles and does not address the need to tag existing resources or enforce the tagging strategy for future resources. Therefore, incorrect choice. We'll lock option C as the correct answer. Okay, let's tackle this question now. We'll first look at option A. E says lower the set number of RCO and WCO for the table. Simply reducing the provisioned RCO and WCO could lead to insufficient capacity during peak hours and potential throttling. Therefore, incorrect choice. Let's move to option D. D says buy a 2-year reserved capacity plan that covers the peak usage for the 4-hour period each day. So purchasing a reserved capacity for 2 years to cover only 5 hours of the peak load each day would not be a cost-effective solution compared to paying for actual usage what is required. Therefore, option D is out. Between option B and C, we got to choose a better option. If we read the question, there is no mention of specific time of the day when the peak hour starts. It can be like 8 a.m. or 11 a.m. or maybe 7 p.m. etc. We just have the information that the peak hour lasts for just 5 hours in a day. Hence, the safest and the best option to tackle such scenarios is to leverage the power of auto scaling. Hence, we'll keep option C and reject option B and lock it as the correct answer. Alright, as a solution architect, we need to have some coding experience, not much in detail, but we sometimes might need to help the developers as well as a part of our job. So that's what this is all about. So let's first look at option A. A says implement an edge optimized API using Amazon CloudFront to store and serve API response. So as per the question, the comments are dynamic and frequently updated. Caching would not be the suitable for real-time updates. Therefore, A is out. Let's move to option B. B says adjust the blog's code to periodically call get comments at 7 seconds intervals. So this approach is known as polling. This can lead to unnecessary network traffic and latency since it requests data at regular intervals regardless of whether there are new comments or not. Hence, incorrect choice. Let's move to option C. C says use AWS AppSync and leverage WebSockets to deliver comments. AWS AppSync supports real-time updates with WebSockets, which is a protocol providing full duplex communication channel over a single TCP connection. This allows for a more efficient and immediate delivery of new comments to users, enhancing the real-time interactions on the blog post application. Hence, this can be the potential answer. Let's park this. We'll move to option D. D says modify the concurrency settings of the Lambda functions to quicken API response times. While increasing concurrency limit can help with the handling more API requests simultaneously, but it does not address the aspect of real-time delivering comments as they are posted. So therefore, incorrect choice. We'll lock option C as the correct answer. Alrighty, let's now look at option A. A says employ Amazon Kinesis Data Firehose for data delivery to Amazon Redshift. As per the requirement of the question, the data needs to be stored without the need for predefined schemas. So Redshift, if we look, requires predefined schemas. Hence, incorrect choice. Let's move to option B. B says use Amazon Kinesis data streams to send the data to Amazon DynamoDB. Kinesis data streams is the best fit whenever we have keywords like real-time data streaming. And Amazon DynamoDB we know is a NoSQL database service which doesn't require fixed schemas. So that is what we also require as per the second part of the question. So this looks good. We'll park this. Let's move to option C. C says opt for Amazon managed streamings for Apache Kafka, Amazon also known as Amazon MSK, to route data to Amazon Aurora. Aurora is a relational database that also requires predefined schemas for data storage. So therefore, since Aurora requires schemas, so we will eliminate this just like Redshift. Let's move to option D. D says choose Amazon Kinesis Data Firehose for sending data to Amazon Key Spaces for Apache Cassandra. So while Amazon Key Spaces does support schema-less data storage, so this would suffice this part of the question, but the use of Amazon Kinesis Data Firehose is not the best fit for real-time data processing, as Kinesis Data Firehose is most suited for batch processing. So batch processing is not mentioned in the question anywhere. So we'll reject this. So we are left out with one option and it is the correct answer. So please don't go away. Let's meet in next part of the series where we'll be covering hands-on related to EC2 Inspector to check for vulnerabilities, start from the scratch, and also tackling some quiz.